So here is one of the roof campering that is shown here. So you can see how it is cambered here. So there will be a small inclination that is provided here. So it is not a flat edge that is provided on the roof of the vehicle, but also you can see the side planning here. There is a small cambering that is shown at the side panel here. Uh, so it is not a flat surface. There is a small side paneling, and in sometimes you can also see there will be some pathways for air to move here. Okay, a small cambering here, and then another cambering here, and there will be a depression here, and this depression is formed or given to provide the smooth airflow at this point. Okay, that is the only function of it, and otherwise a side panel cambering is provided at the vehicle. So the next feature is uh, rear side panel taper. Rear side panel taper. So to find the rear side panel taper, you have to look at the top side. Okay, you have to see the top view of the car, and at the top view of the car you can see there will be an inclination provided here. Okay, after the side cambering comes here, there will be a small inclination provided at the rear side. So it is the side. It is at the side of the vehicle rather than the rear end, but it is the rear part, and it is the side of the vehicle. At the side of the vehicle, you are providing a small inclination, and you can see here various points are provided here: x1, x2, x3, and x4, and each inclination is shown here: x1, x2, x3, x4. Each are the inclinations that are provided here. Okay, this is the drag coefficient here, and the taper is provided in the x-axis, and you can see it is in mm. So x2 is the point at which taper is provided at 50 mm, and x3 about 120 or 130 mm, and then x4 is the 200 mm. So you can see here the coefficient of drag decreases from x1 to x2, that is from 0 when you are providing no taper angle, that is x1 condition, and at that condition the coefficient of drag is 0.4, and it reduces to 0.38 at x2, and x2 is about a 50 mm taper that is provided here. Okay, the first taper that is provided there, and at x2 the CD of A will be about 0.38, and further moving on to x3, the coefficient of discharge is again lowered to 0.34. And while comparing x3 and x4, so any further reduction, you will get a constant coefficient of this drag value. Okay, the drag coefficient will be at a constant value, that is 0.34. So even if you increase it after 200 mm, we will still get the same drag coefficient. So the reason for reducing or tapering this side is nothing but if you are reducing this side also. Imagine if you have also reduced it up to x4. So the region that is formed behind the car. So you know that one of the reason for aerodynamic drag is base drag, and base drag occurs due to the vacuum that is provided at the uh, rear end of the car. So due to the vacuum formed here, a higher pressure region is always present at the nose of the vehicle, and due to the pressure difference, movement of high to low pressure, there will be always a pressure difference, and drag will occur onto the vehicle, and such a drag that is occurring behind the vehicle is known as base drag. And when we are looking at the taper or the side panel taper that is provided here, you can observe that the area that will be formed here. Okay, the area that will be formed here will be restricted to this distance. Okay, the inclination that is provided similar to x4 at this end, then the length here will be decreased. So the area of vacuum occurring behind the vehicle will be lessened, and due to that the base drag also decreases. So that is what is happening when we are tapering. So if you are not tapering, you look at the figure without any taper, that is the x1 condition, then this complete length is provided for the area as base drag. It will be facilitated for the base drag area. Okay, that is the problem occurring. And if you are providing a taper, that area is decreased and you can't decrease it any further. Further reduction also results in the same area that is forming here. That is because due to the rear of the vehicle, that we'll discuss next uh, uh, in the next point. So you can see the the area is decreased here, and due to that, base drag decreases. So that is what is affecting rear side panel taper. So next is the rear end panel taper. This is not a side, it is a rear end panel taper. So rear end panel taper is nothing but you are providing a taper underneath the car. So I'll show you. So this is the rear side taper. Okay, you can see the area that is decreasing here. So here comes the side camber, and after the side camber, you can see the area consistively decreases. So there is a decrease here, and a taper is provided here, and yeah, here also it is provided. So the area of vacuum pressure that is created behind the vehicle is limited to this length. Okay, so this is the rear side taper, and in the rear end taper, you can see the cross-sectional area here decreases, and after this point, after the rear end wheel, we are providing a taper upwards. You can see an inclination provided here. So the benefits of providing a taper here is nothing but to increase the negative lift. To increase the negative lift. So I have already told you the velocity of the air underneath the car will be very high. Um, at the front of the vehicle it will be low, and the high pressure region will be created here, but underneath the car always the high pressure region is here rather than upwards the car, and hence it will always provide a lift at the center of the car, while we have to provide a negative lift at this portion of the car also. And for that purpose we are increasing the area here, and while increasing it, the velocity here decreases, and the pressure here also decreases, and the region of high pressure will be created above the vehicle, and hence it provides a negative lift, and that is how it affects the lift. While in the case of a drag, you can see here, so it is the angle that is provided by the chassis and the uh, chassis and the taper. So it is the angle beta that is shown here, and you can see how the coefficient of discharge varies. So initially it increases about 5 degree. So this is a 5 degree increase, and then it decreases gradually, but after some time it increases also. Okay, after about 20 degree it increases. So 20 degree will be the limit of tapering that should be provided at this vehicle. Any further it will increase the coefficient of drag, and that I will explain it to you when I am discussing a component called diffuser. So it is also known as this taper, and is also known as diffuser angle, and a diffuser is a component that is extra fitted into the vehicle rear end for smoother airflow transition. So I will explain it to you when I am explaining diffuser. So rear side panel taper is also known as diffuser, and this angle is known as diffuser angle. Just know that diffuser is another component that is fixed here, but it is normally known as rear side panel taper. Okay. Next is a rear and tail extension. Okay, rear and tail extension. So we have seen various vehicles, and at each condition there will be a tail extension. Maybe it will go to the point of 1 that is shown here, or it will be about 2, 3, 4. So each are all conditions for tail extension. So tail is nothing but the rear end. We are providing cargo space and all. And for that, we are provide each tail extension is shown in the figure, and I will show you another extension. So you can see here, this is a form of tail extension, while here the tail extension is much greater. Okay, so this is the example for a tail extension, and you can see how CD varies. So you can looking here itself, you can see this is the CD at the y-axis, and this is the tail extension in mm. So in the first condition, in the fourth condition, you can see here, fourth condition, the CD value will be much higher, while here at it on increasing it, the CD value decreases. And at the point 1, you can see it will see the most minimum. So what is happening here is nothing but when you are providing no tail extension, the area that is being used for base drag, the area which will be coming under influence for base drag will be much greater. So you can look here itself. When there is no tail extension, this is the line that is shown here. And when there is no tail extension, there will be a huge area. But when coming to 4, there will be a reduction in that area, and 3 a further reduction, 2 another reduction, and at 1 it is 0. So the 1 is a theoretical concept, and it is not found that much. It is there, but it is not found that much because it is not ideal for maneuvering the vehicle. But if you are providing it till 1, there will be no disturbance in the airflow. Okay, it is in the same shape as that of an aerofoil. So if you look at a whole direction, it will be in the form of an aerofoil. So inside an aerofoil, there will be no disturbance or turbulent flow at this point. Okay, and that is what is shown at the point 1, but it is not practical because of the huge length of the vehicle, and the maneuverability of the vehicle will be difficult. So about 2, or you can see the coupe that is shown here. So each cases of tail extension is there, and according to the tail extension, the region that is formed here will be lesser. So you have to reduce this area. So if you are reducing the area behind the vehicle for turbulent flow or the vortices that occur, then the base drag will be reduced, thereby reducing coefficient of drag. So that is the importance of a rear end tail extension. And the last one affecting uh, coefficient of drag is underbody roughness. So what is underbody roughness? Underbody roughness is nothing but we have various components that is present underneath a car. So if you are looking underneath the car, you can see in conventional vehicles, that is old vehicles, you can see there will be a propeller shaft, differential, the gearbox, and the exhaust pipe, exhaust manifold, catalytic converter, and each and everything is fitted underneath the vehicle. And air has to pass impending on all these parts underneath the vehicle. So it has to incident, or it has to strike each and every part to reach the rear end of the vehicle. From the front end to the rear end, the air has to travel underneath the car. And each point, it has to strike each and every gaps and nooks and each holes and cavities. It has to pass through all that point. So if you are providing such a design, or if you are providing such an bare exposed underneath part of a car, then the coefficient of drag will be much greater. The coefficient of drag obviously will be greater because the air has to travel by striking at each and every point. But in modern cars, you can always see that the chassis, every component is mounted above the chassis rather than below it. So it is always mounted above the chassis, not in the case of heavy vehicles, but that of a light motor vehicles. Okay, in light motor vehicles, you can see every components are mounted above the chassis, but sometimes the exhaust manifold only is provided below, because the exhaust manifold is operating at a higher temperatures than other components, and providing it above the chassis may result in some kind of accidents, and to reduce that, only the exhaust manifold and the exhaust system is provided underneath the chassis. So this reduces the air striking at each and every point and increases the velocity, and obviously the air can smoothly travel back to the rear end of the vehicle. So you can see here itself. So this is an old car. You can see each and every components. This is a heavy vehicle basically, and you can see each and every components that is present here. Okay, then the engine and the engine oil sump etc. are shown here. Okay, but in modern vehicles you can see it is almost basically covered here. Okay, and even if it is covered, you can see it is wedged here. You can see these are all in a same parallel line. So the exhaust manifold is fitted in a nook that is provided inside the chassis itself. So it is sitting inside the chassis, but it is underneath the chassis. So that is how it is sitting here, and then it is provided to the rear end. But still, and you can see there are some pathways that is provided here on the underneath of the chassis, and this facilitates a smoother movement of air. So you can see here also the engine part or the engine cover is shown here, and this path also pathways are also provided on the engine cover that is shown here, and it facilitates the smoother movement of air underneath the car. So that is what is underbody roughness. And underbody roughness, there is no graph. It is shown about large ground clearance and small ground clearance. So this graph is not respective for the roughness, but that of the ground clearance. So obviously the coefficient of drag will be lesser for large ground clearance than smaller ground clearance. Okay. So the next topic is about aerodynamic lift control. So we have discussed for the last session was on aerodynamic drag, while the next one is on aerodynamic lift control. So the various parts that are used is underbody dams. So first one is underbody dams. So what is underbody dams? As the term suggests itself, it is underneath the body. So it is below the body, but it is not underbody roughness, but rather dams. So what is the function of a dam? Dam is nothing but, you know, hydroelectric dams and all, right? So dam always prevents something from moving in that particular direction. So in the case of hydroelectric project, it stores the water, or it prevents the water to follow its natural path of flow. So we are controlling that flow, right? So the same way we are controlling the airflow pattern, or how the air flows underneath the car. So there are two underbody dams that are provided here, one at the front end and other at the rear end. Okay, there are two reasons for that. At one condition I have already told you, in the rear end, if there is a positive lift occurring, it also facilitates the movement of it also facilitates the gripping of the front end of the vehicle to the ground. So if there is a positive lift that is occurring at this rear end, it facilitates, because of this tilting here, it is going upwards, here it will go downwards, always it will go downwards, and due to that the front end will be always gripping the road. So that is facilitated by the positive lift that is provided here. It is even if this happens, there is no matter, we just have to obtain negative lift at the front of the vehicle. But while tapering the vehicle, we always get negative lift at the rear end and also at the front end. Even if you obtain a positive lift at the rear end, it does not matter. And one of the cases shown here. So we are providing two components here. You can see a bulged section here and another bulged section here. So here, this dam restricts the air entering underneath the car. So it will provide the most amount of air to travel over the car. it will be going over the roof of the car rather than underneath the car. So when you are directing most of the air above the car, we will obtain higher pressure regions always over the car rather than below the car. That is the function of providing a front end dam. So we will restrict that air, and while the air travels here, obviously the velocity will be high and the pressure will be high, but we are reducing the amount of air that is entering underneath the car. Here, for providing positive lift, we are reducing the cross-sectional area. You can see here, we are reducing the cross-sectional area here even smaller than this one. So obviously the velocity will be increasing, and then a region of high pressure will be created and a positive lift will be occurring at the rear. But if you are providing a rear end taper, there will be a negative pressure created here because of the lower pressure here and the higher pressure occurring here. There will be a negative lift. So that is how the dams assist in reducing lift. So you can see one of the underbody dam that is provided at the front of the vehicle. So this is the underbody dam that is provided at the front. So this facilitates the air to most of the air to travel upward to the car rather than underneath. Air flows underneath the car, but due to this design, the major of the air is directed upwards due to this inclined portion provided at the front fender. So this is one of the underbody dam. And in the case of a taper that is shown here, that is underbody dam that is provided behind the vehicle, such a force is occurring due to the lower pressure that is generated here and the higher pressure that is generated here. Okay, and one of the component assisting for that is diffuser. So this is the diffuser that is shown here. If you are looking at the sports model cars, etc., you can see at the rear end of the car there will be a component that is fitted to the car underneath the taper, and this is called a diffuser. So the function of diffuser is nothing but to safely transition the air to the atmosphere. So you always know that the behind of the vehicle there will be a vacuum formed at high speeds. Okay, and there will be a turbulent flow. So one part of the air that flows above the vehicle comes and falls in this direction, while underneath the car it also forms in this direction, and a region of negative pressure is created here. But this two incoming air streams from the top and the bottom of the vehicle collides at a point further away from the rear end. It will collide at a point, and this point, if there is no sufficient transition of air that is shown here, a significantly greater region of lower pressure will be created here. Okay, once more I'll tell you, the airstream that is moving up above the car moves and strikes the airstream underneath the car at a point away from the rear end of the vehicle, and once they mix together, due to the opposing direction of motion of airflow, there will be a huge disturbance occurring at the behind of the car, and this further reduces this area of it further reduces the area behind the uh, rear end of the vehicle and facilitates the aerodynamic drag or the base drag to increase, and this is undesirable. And for that purpose, if you are providing a diffuser, it smoothly transitions. So what happens is that at this portion the velocity of air decreases, and we are providing a pathway for that air to move in a safe manner or at a lower velocity and strike the incoming air from the top of the vehicle and smoothly mix each other. And for that purpose, a diffuser is provided. So an underbody dam, we are also providing a diffuser. Okay. Next component is, okay, you can see here, uh, the drag here, the drag reduces at to this point and then increases. So you can only provide a sufficient amount of front dam and a rear dam, and you can see the front lift is reduced by using front dam. So the majority of the air always travels to the upward portion of the car rather than the bottom of the car. And in the rear lift you can see it increases. Rear lift is increased in this case. Okay, rear lift is increased in this case because a positive upward thrust is formed in this case, while in this case it is reduced, and you can see it reducing here. Okay, there is a small reduction here. That is where when using diffuser. And a major portion of, sorry, that is when you taper this one. This portion is for taper, and for this reduction we are using diffuser. Okay, we are using diffuser for reducing the rear lift. So that is what is coming under underbody air dam. Next is the exposed wheel airflow pattern. So in exposed wheel airflow pattern, you have always noticed that the tires or the wheels that are provided in a vehicle are always open wheels. So the purpose of providing open wheels rather than enclosed wheel is nothing but for the air to travel safely outside. So you have to send the majority of the air uh, encountering at the front without any restriction smoothly to the sideways rather than underneath the car. If you are sending it underneath the car, always a region of high pressure will be there and the lift will occur. And to reduce that, we are providing open wheels. So in an open wheel condition, this is how a flow occurs. So this is a Formula One car, and in that you can see the air that is striking at the front nose end of the vehicle is then uh, front side of the nose end of the vehicle is then transferred to the atmosphere through the open wheel pattern. So this is how it falls in an open wheel pattern. So this is when we are looking at the at this direction. Okay, so if we are looking at from the front end, there is also a possibility of the air going underneath the car to rotate in this manner due to the rotation of the wheel. So there are two patterns of airflow. First is through the open wheel, and another one is inside the enclosed space of the tire. So you can see the tire always rotates in this direction, right? In the forward direction. So it carries a small amount of air in this manner also, and it has to be safely ejected here. You can see, so there will be a design that is provided here, or a pathway that will be provided at this portion of the vehicle to safely produce a small vorticity. So you can see there's a vortex formed here, and by this vortex or this turbulent motion, the air exits from this point. But majority of the air that is entering the vehicle rather than the tires will go underneath the car. So the wheel is only exposed for a small area of this front of the vehicle. The other of the the rest of the air always moves underneath the car. So this is how an airflow pattern occurs. So this is an open wheel airflow pattern, while this is the enclosed wheel airflow pattern. So that is the partially enclosed wheel airflow pattern that which I have discussed. So when you are looking at the top side, you can see how the turbulent flow is occurring. Okay, this is how the turbulent flow occurs here. So once it exits, the vorticity that is formed here is in this manner. And while looking at the drag coefficient, you can see how it reduces. Okay, drag coefficient also reduces, and also the lift coefficient also reduces due to the provision of open wheel system. Okay, this is how the drag and also the lift reduces. Next is the rear end spoiler. So I have already talked to you about spoiler. So spoiler is nothing but uh, a shape in the form of an inverted aerofoil is provided in the behind of the car. Okay. Uh, Basically, this is a retractable spoiler. You can see here. So it always ensures that positive lift occurs, sorry, negative lift occurs at the rear end. That is the function of a spoiler. Okay. So this will be provided on the vehicle. This will not be an extra attachment. So you can see here, this is an extra attachment that is formed. So this part that is shown here, right? This will be always present in the vehicle. Okay. Such a design will be present at the rear end of the vehicle. And this is the spoiler part. And that spoiler, due to this shape, will produce a higher pressure on top of the car rather than below. Okay, it will provide a higher pressure here due to the high velocity flow here, and then there will be a region of low pressure here, and due to that a negative thrust is formed at the rear end. That is the function of spoiler. And additionally, the next component, so you can see here, this is the front lift. So if you are looking for a front lift by using a spoiler at the front lift obviously will increase. The lift will increase. So we are not using a spoiler at the front, but at the rear lift, you can see the rear lift decreases. This is because a negative lift is created at this point due to the aerofoil at this point. Okay, and according to the degree of inclination, so if we are looking at a retractable spoiler, it can bend in different axes. So if you are uh, bending the spoiler in the downward direction, obviously there will be a positive lift occurring rather than a negative lift. But if it is bent upwards in the shape of an inverted aerofoil, then we are obtaining negative lift. Okay, that is the manner in which the retractable spoiler works, and the such a method is used in sports car for easier maneuverability, and for that easier maneuverability we are using a negative lift aerofoil wings. What is negative lift aerofoil wings? So that is what is shown here. Okay, so in this vehicle you can see that this part with the emblem on or the logo on is known as the spoiler. This is the spoiler, and any other extra attachment other than the spoiler that is provided on this vehicle is the negative lift aerofoil wings. This is another wings that is provided in the vehicle. So this is provided because once the vehicle attains a certain speed, it will obviously tip over. And to reduce that or to provide negative lift at the rear end, these wings are used. So it ensures always that negative lift is formed at the rear end of the vehicle. So for that purpose, a negative lift aerofoil wings is given. Okay, with that, I will wind up today's class. I'll take the attendance.